So we were doing a factor theorem yesterday, right? Factor theorem, which is goes hand in hand with the remainder theorem. Here, this question is asking us find the remainder when this guy is being divided by these dividers. So how do we do this? If you remember from yesterday.
I don't remember.
Okay, so there's three different ways of doing this, right? The quickest way of doing this is to find the k value. The k value just means the x-intercept here. So the first one will be the x-intercept.
2.
2, right? So you just plug 2 as x. You simply do f of 2. You simply find f of 2. So that's going to be what does that mean? You just replace all the x's with 2's. You see all the x's here? So it'll be 2 power 4 plus 5 times 2 cubed, like that. And this one, you can just plug this in a calculator to save time. Right, let's see what this gives us. So 2 power 4 plus 5 times 2 cubed plus 3 times 2 squared minus 7 times 2 plus 10. Plus 10, not minus 10, which gives me 64. You see, it's easy as that. You find the k value, you plug it in there. What's the k value of this? 2x minus 5. Again, k value just means the x-intercept.
Negative 5 over 2.
Positive 5 over 2.
Oh, okay.
Because you have to set this equal to 0, right? And then you'll get 5 over 2. So this is the fastest way of doing this, right? So tell me, we got a remainder of 64. Is x minus 2 a factor of f of x?
No.
No, it is not, right? No, it is not. We know the remainder is 64. Now let's do it the traditional way because, and let's see which one you'd prefer. So we're going to do long division here, and hopefully we get the same answer because that is going to be the goal here. Minus 7x plus 10. What do I put up here?
X squared.
No, not x squared. Try again. Is x 4 over x? How many times does x go into x4? X squared times? No. It's too small.
Oh, X cubed.
Yeah, x cubed. What goes here?
X4.
Yeah, x4 minus 2x cubed. Okay, like that. Now we subtract them. When you subtract them, this always cancels out, and this is going to change the sign. 5x cubed plus 2x cubed is 7x cubed. We kill something, we are allowed to bring something else down. Now tell me what goes up here.
7x squared.
Yeah, so plus 7x squared. Then you'll get 7x cubed here minus 14x squared. You understand how we got the minus 14?
You multiplied?
Yeah, so negative 2 times 7x squared is minus 14. And you subtract, this cancels out. This is going to become a plus. Add that up, 17x squared. We bring the other guy down. And then you put a plus 17x here. 17x squared minus 34x. This cancels out. This becomes a plus. 34 minus 7 is 26 or 27. Yeah, 27x. You finally bring this guy down plus 10, right? Then you put up 27 here. So this becomes 27x minus 64, right? Or minus 54, sorry, minus 54. This cancels out, and then this becomes a plus. 54 plus 10 is 64. That's the remainder. So that's how you do it by long division. But again, it's very inefficient, right? We can always use the factor theorem. Now let's try doing this using synthetic division. Again, synthetic division uses the k value. The k value comes up here. We know the k value for this one, x minus 2, it's 2. So put a 2 here, and you're going to write all the coefficients here in descending order. from their degrees. So 1, 5, 3, negative 7, 10. How do we do synthetic division? This is how it works. You see this first number here?
You bring it down.
Yeah, you bring this down as it is. And in synthetic, we always add. And then up here, you do 2 times 1 goes up there, you add, you get a 7. You see that?
Mm-hmm.
And then I can do 2 times 7, it goes up here. So that'll be a 14. And then you add them 17. 2 times 17 is 34. You add them, that's 27. 2 times 24 is 54, and you add them, you get 64. And in synthetic division, this last guy will always be a remainder. This is gonna be your quotient, right? And again, we're dividing x4 by x. That means this guy must be x cubed. See? So our quotient is 1x cubed plus 7x squared plus 17x plus 27. That's our quotient, that's our remainder. And look at this, it's the same thing, right? It's the same thing. Synthetic is way quicker though, I think. Objectively, synthetic is definitely quicker. But when do we use synthetic? It has a restriction. Long division, you can use it at any time, right? What's the restriction on the synthetic? Your divider, right? This guy
Has to be linear.
has to be linear. Like if this was x squared minus 2, we could still do long division, but we could not do synthetic.
Mm-hmm.
So exactly. So in this question, if they asked us, and also the factor and the remainder theorem also wouldn't work. Like if it asked us find the remainder when we're dividing by x squared minus 2, the k approach doesn't work. Factor theorem doesn't work. Remainder theorem doesn't work. Synthetic doesn't work. You have to go the long route of doing long division.
Uh-huh.
When we're trying to do long division with this, again, if there's a missing thing, you have to put that as 0. Because see, x squared, we're missing an x, so I'm going to put a 0 like that. And then you do your normal long division. And then the remainder will be, yeah, you're going to have to do this manually, okay?
Okay.
We won't see much questions like that, though. All right, let's do some question here. Which one is looking... All right, let's do the hardest one. It says factor, all right? It says factor. Whenever you're trying to factor something, doesn't matter, quadratic, cubic, quartic, quintic, septic, whatever, doesn't matter. If you can pull something out, right? If you can pull something out, if your goal is to factor, always pull it. Look at this question. Can we pull anything out? Do they all have something in common that we can pull out?
X.
Yeah, they all have an x. So we're going to pull out an x. If we pull out an x, what are we left with?
X to the power 4 minus 5x cubed minus 7x squared plus 29x plus 30.
Plus 30, exactly. Good. Plus 30. So this is going to be our first step. See, this one automatically tells us that one of the x-intercepts is 0. Because if this x is 0, the entire thing is 0, right? If x-intercept is 0, that means y-intercept is also automatically 0, okay? And which we could have seen right here, because the y-intercept is always the constant in its standard form, unfactored form, standard form. Here we're adding a 0, y-intercept is 0. We knew that to begin with. Now we need to factor this quartic function inside of it. I'm going to call this f of x. This thing inside the bracket, this is f of x, okay? It's f of x. So to factor this, we need to find the k value that will give us a remainder of 0. Now to do that, we have to list out the factors of 30. What are the factors of 30?
3 and 10.
There's way more than 3 and 10.
And 5.
Yeah, so 3, 5, 10, more. For the purposes of this, actually this is true. 1 is a factor, okay? Because we're always going to start out with 1. 30 is also divisible by 2. 30 is also divisible by 6. 30 is also divisible by 15. There you go. Those are all the factors. And then again, their negative components are also the factors. And trust me, you'll never have to check for these. You'll just list out the first few, I guess. One of these will always work. Actually, here, let's talk a bit about high school. Because this is the normal Canadian high school, okay? Question.
Mhm.
But if you were doing something a little bit more advanced, it's called you can still do it in Canada. There's something called A levels, okay? There's something called the IB program. This is what I did. There's something called the gifted program, and a lot of Canadian high schools, they offer this, which goes a bit beyond the normal high school curriculum, okay? In these, you also have to check for some weird numbers. Look at this. 1 over 2, 0.5 is a factor of 30. So you'll be checking for 1 over 2 as well. 1 over 3 is a factor of 30, because if you just multiply 1 over 3 by 90, you get 30, you see?
Mhm.
So you'd have to be checking these things. So it gets a lot more complicated. But this is Canadian high school, so you don't have to worry about that. But I'm telling you, if you were to do any of these, the math gets a little bit more complicated. And even plugging the fractions in here is not very fun. Anyways, so we're going to start off by checking for -1, okay? F of -1. Or actually, let's just check +1, because that's the easiest. 1 minus 5 minus 7 plus 29 plus 30. There's no way that's a 0. +1 is out. -1 is looking good, though. -1 is definitely looking good, because this will become negative. This is going to become positive. Let's see -1. So -1, 5 is just -1 minus 5 times, that's going to become that. This is going to become plus. This is going to stay as plus. This is going to become minus. This is, I think, going to work out. -1 minus 5 plus 7 plus 29 minus 30. Yeah, this one works out. There we go. -1 is our guy. So that's our k value. What is it as a factor? You see the question that we did before? We found out the k value was +2. The factor is x minus 2. Here the k value will be -4. The factor is x plus 4. You see that?
Mhm.
So if the k value is -1, what is our factor?
X plus 1.
There we go. So that's what we do. So here we'll say, therefore, x plus 1 is a factor of f of x. Okay?
Mhm.
Now, what's the next step? We've identified the factor. We're going to have to divide. You see, we're going to have to divide this f of x by our factor,
Mhm.
which is going to give us a cubic quotient, because x4 over x is x3. Okay, we're going to do divide. It's going to give us x3. And then to factor x3, we're going to repeat the process. We're going to look for its constants. We're going to look what it's divisible by. So it's going to be a two-step repeating process. So the next step here would be to divide our f of x. By the way, this is our f of x. Yeah, this bracket is our f of x. We're going to divide this by x plus 1. I'm going to use synthetic because, like I said, synthetic is way quicker. So to use synthetic, you put your k value here, which is -1, yeah? What do we put here? What are the coefficients of f of x? What's the coefficient of x4?
1.
1, right? So now what's the next one?
-5.
-5.
-7. 29 and 30.
There we go. That's our setup. Synthetic, the first number always drops. Tell me what goes here.
-1.
Yeah. And we add. What goes here?
-6.
Yes. What about here? Keep going.
+6.
-1, right? +1, 30. -30, 0. We know this was going to be 0 because we know that x plus 1 is a factor, right?
Mhm.
So what is our quotient here? Because that's what we're most interested in. Are you able to read this off? What is our quotient actually? We divided x4 by x plus x basically. It's going to be x cubed, okay? It's going to be x cubed. So let's assume f of x is 20. We're dividing 20 by 4. Our quotient will be 5, yeah? This is the divider, yeah? This is our quotient. So instead of writing 20, we can write 4 times 5, which is what we're going to do next. So x in the front stays as x, but this guy, we're going to write this as our divider, which is x plus 1. What's our quotient here? Read this line.
X cubed minus 6x minus x.
Plus 30, okay, like that.
Mm-hmm.
So that is our quotient. Now we're going to repeat the entire process again. What do I mean by that? Now I'm going to call this new bracket g of x, okay? So we don't mix them up. G of x. Now we need to factor g of x, okay? It's a cubic function. How do you factor a cubic function? It's the same idea as the quartic function that we just factored. What do we do? Well, you got to look at the constant, right? The constant is 30 again, yeah? See, this number is 30 again. We need to find the factors of 30, which we know from before. What are the factors of 30?
1, 3, 5, 6, and 10, and 15.
Yeah, 10, 15. But we don't need to go all the way down. It's usually the first few is going to work out, okay? So again, look at this, pay attention to this step, because to factor a cubic quartic, doesn't matter what it is, you look at the constant, you list out its factors, and they're going to test it to see which one will give you a remainder of 0. So let's try g of 1. G of 1 is automatically out. There's no way that's going to be a 0. So we don't even have to bother with 1 or negative 1, because I can already tell it's not going to be big enough to kill the 30. So 1 is out, right? Just by inspection. Because this can either be 1, all of these 3 terms will be plus minus 1, but that's not enough to kill plus 30. So plus minus 1 is out. We can start by checking with a 2. So we're going to check for g of 2. And again, this I'm going to do it in a calculator. So 2 cubed minus 6 times 4 minus 2 plus 30 gives me a 12. 2 is out. What about minus 2? Minus 2 cubed minus 6 times 4 plus 2 plus 30. Minus 2 is good. Okay, I plugged minus 2 as x in g, and that gave me a 0. So what is our factor?
X plus 2.
Yeah, exactly. X plus 2 is a factor of g of x, x plus 2, right? And now we're going to divide g of x by x plus 2. Okay, and we're again going to use synthetic. Our k value is negative 2. So negative 2, what goes up here?
1, negative 6, and 1, and 30.
Yeah.
Negative 1 and 30.
Boom, 1 goes here. Look, this is very quick. Negative 2, negative 8, 16, 15, negative 30, 0. Boom. It's really quick if you know what you're doing, obviously, right? Long division, no one likes to do long division. Trust me, no one likes to do long division. But sometimes you don't have a choice, because if the divider is bigger than linear, then yeah, you're toast. So tell me here, we're going to rewrite the g of x function, okay? How can we rewrite the g of x function? It's going to be something times something. Our divider times our quotient. What's our divider? What's the factor, basically? What's the factor? We're dividing by negative. So we're dividing by -2, so what does that mean for our factor? Our factor is right here, x plus 2 is our factor. Okay?
Mhm.
X plus 2 is our factor. What's our quotient? Look down here. We're dividing x cubed by x, right? So what will be our quotient?
X squared
Yeah,
minus 8x plus 15x.
there we go. Just 15, yeah? It
Mhm.
goes 1 degree at a time, just 15. Now we're done with that part as well. Now we're finally going to factor the quadratic. What does it multiply to? What does it add up to?
It adds up to -8 and multiplies to 15.
Right, and what are the numbers? Numeros.
-5 and -3.
Right, -5 and -3. So again, look at this. The coefficient here is a 1, right? When the coefficient is a 1, if you have the numbers, you can straight up write that, to save some time, as x minus 5, x minus 3, like that. Alrighty?
Mhm.
But if it wasn't 1, then yeah, you'd break it down and factor 2 things at a time. Anyways, this is the final answer. We've completely factored this quintic function. Tell me the x-intercepts. We can quickly make a rough sketch of this. There are 5 x-intercepts.
-1, -2, +5, +3,
There's one
and
more.
0.
Yeah, 0. The y-intercept, if x-intercept is 0, y-intercept is automatically 0.
Mhm.
Bada boom, bada bam. And now we go up here. Which quadrant does x5 start? Where does it end? Positive x5.
Starts in 3, ends in 1.
Yes. So ends there, starts here. And our x-intercepts are -2, -1, 0, 3, and 5. That's all. Okay, and you can just join the dots. Goes up, again, this part is not important. There we go. And that's a sketch, a rough sketch, right? We don't care about the highs and the lows here. If you want to know what these are called, this one and this one, they are called, there's a name for them, because those are like the peaks there, right? The high points there. These are called the local maximums. Just local, because it's not a maximum. Because this goes on forever, right? Our maximum would be, y is going to go to positive infinity. There's just a maximum in this local region, okay? And these two, what do you think they're called using the same logic? Local what? Yeah, local minimums. So we won't be finding them in this course, but they do exist. And maybe eventually if you get to it, I can show you how to find them. A lot trickier, very tricky to do that. Okay, this question we did yesterday, okay? But now this is a very, very common question. When some polynomial is divided by x minus 1, the remainder is 10. Let's call this f of x. Can you tell me in mathematical terms, what does this mean? Divided by x minus 1, the remainder is 10. What would I write here? Again, this has to do with the remainder theorem. That's just a fancy way of saying this, right? That's just a fancy way of saying it. If we're dividing by x minus 1, what is our k value?
1.
1, right? So that's all that's saying is when you plug 1 into f of x, okay, what do you get as a remainder? 10. You understand that? This is the crux of the remainder theorem, right? You have some function f of x, your dividend. If you divide this by some factor, x minus a, or some other function, x minus a, your remainder is going to be f of a. Okay? Same idea. We're dividing by x minus 1. That means to find the remainder, we'll just plug f of 1 equals 10. So if you plug x as 1 in f of x, right? So you get a times 1 is just a, minus 1 squared is 1, 2 times 1 is 2, plus b equals 10, like that. So in this one, let's solve for a. Let's make a the subject. What does that mean? That means I want a on left side and something in terms of b on the other side. How do I solve for a in this? Well, this is a linear equation for our purposes, but it's a multivariable equation. It is linear though. Same rules apply as a linear equation. We're trying to solve for a. Well, if it helps, look at this. Negative 1 plus 2 is just 1, right? We're trying to solve for a. Let's subtract 1 on both sides. And then what do we do? Just subtract b. Yeah, that's it. It's easy. It's easy like that. Okay, just subtract b. A equals 9 minus b. Cool? And now we're going to get a second equation from the second statement. And tell me, we just did this, right? This is very similar to this one. When it is divided by x minus 2, the remainder is 51. What do I write here? It's pretty much the same thing as we did here. Something will be equals to something. Just follow this pattern. It's going to look very similar to this.
F of 2 is 51.
Exactly. Do you understand that? Because that is the remainder theorem, right? That is the remainder theorem. When you plug the k value into the function, you get 51 as a remainder. And now we're going to plug 2 into f of x. So it's going to look like this. A times 2 cubed minus 2 squared plus 2 times 2 is a 4 plus b equals 51. And we can kind of clean this up. 2 cubed is 8. So we have 8a minus 4 plus b equals 51. The 4's cancel out, yeah? And then we can, what's a actually? Look at this. A is actually 9 minus b. So we're going to do a quick substitution here, okay? That's going to become 8 times 9 minus b plus b equals 51. How do we find b?
You divide by 8?
Nope.
You divide by 9 minus b.
So you can't do that because there's a plus b here, right? So it's like saying this, 2a plus 3 equals 5. Would you divide by 2 or a on both sides? No, that wouldn't make sense. First kill the b, I guess. In this case, no, you wouldn't minus b in this case because you want b's to be on the same side, okay? Because we're trying to group up the like terms. The only thing you could do, this one, there's only one thing you could do. You could divide by 8, it won't help you at all. You could divide by 9 minus b, that would complicate things even more because it doesn't cancel out from either side. Understand this, if you divide by 8, the 8 and this 8 does not cancel out because of this plus b here. The plus b wasn't there, yes, this 8 and this 8 would cancel out, but because of that plus b, that 8 does not cancel out. So there's only one thing you can do. Open the brackets. What's 8 times 9? 8 times 9 is 72, okay? So if I open this bracket, what else do I get? I get something else here. So open this bracket.
Minus b.
Not just minus b. Because we're doing 8 times 9, 72. We also have to do 8 times minus b, which is negative 8b. There we go. What do we do next? We're trying to solve for b.
You subtract 72.
Yeah, you can subtract 72 from both sides, so you get 21. Negative 21, in fact. And you see these are like terms. Negative 8b plus b, what is that? You lost 8 apples and you gained 1 apple. How many do you have?
Negative 7b.
Yeah, exactly. Negative 7b. Divide both sides by negative 7. B is 3. There we go. And you can plug it back in here to find a. So a will be 9 minus 3 will be 6. And we're done.
Okay.
Here, open this bracket for me. We're just opening the bracket. So we're going to multiply this here, multiply that here, multiply that here.
2x cubed.
Yeah?
Plus 6x to the power of 3.
No, not 3. What's x
4.
squared? 4, right? X squared times x squared is x4. You add the exponents. What about the last term?
10x squared.
Yeah, that's it. Okay, 10x squared. Let's look at this one. The polynomial, some guy, has 2x minus 1 as one of its factors. Determine the value of k. We're going to call this f of x. This is very similar to the last question. If 2x minus 1 is a factor, what does that mean in terms of the equation? What does that mean mathematically? F of something is something. It's like we did in the last question.
F of 1 over 2.
Good. Is equals to what? If it's a factor, what's going to be the remainder?
0.
0, right? That's all there is to this question. It's just algebra from here. We're going to be solving a linear equation. So f of 1 over 2 is 0. What does f of 1 over 2 mean? Well, it just means just plug all the x's as 1 over 2, okay? So you have 12 times 1 over 2 is cubed is 1 over 8, plus k times 1 over 4, minus 1 over 2, minus 6 equals 0. How do we solve this linear equation for k?
You add 6 and 1 over 2.
You can also add the very first term here. You can also add this. You see, this is a pure number. This is a pure number. This is a pure number. So we can add all three of these. These are like terms. So let's go ahead and do that. 12 divided by 8 minus 1 over 2 minus 6. So that gives me minus 5. So I got k times 1 over 4 minus 5 equals 0. What's next?
You add 5.
Good. Yeah, you do add 5. K times 1 over 4 is just k over 4 equals 5.
And then you multiply by 4.
Exactly. And you're one and done. Okay. It's a very simple linear equation. So the goal is just see which terms are like terms, which ones you can add, which ones you can subtract. From there, it's very simple. At this point, linear should be pretty simple. All right, let's do something different. Well, it is gonna be something similar, but we're gonna use a formula here. Actually, you remember doing difference of cubes? Oh, sorry, not cubes, difference of squares. A squared minus b squared is a minus b, a plus b. For example, if you have something like x squared minus 9, you can rewrite this as x squared minus 3 squared. So it'll be x minus 3, x plus 3. Do you remember this?
Mm-hmm.
Okay, why don't you tell me the answer to the next question? 4x6 minus 36y8. What does this factor out to? It's going to be something times something. Maybe we'll make it a little bit easier for you. And actually, no, we don't do easy here. You see, something squared is 4x6. What is that? If you square something, okay, you get 4x6. Basically, something squared is gonna be 4x6.
2x cubed.
Yeah, perfect. That's exactly right. What about the other guy? Something squared is 36y8. Very similar. Yeah.
6y4.
Yes. And now we're just going to use the difference of squares formula. A squared, see this entire thing is our a now, yeah? So
Mm-hmm.
a squared becomes a minus b, so 2x cubed minus 6y4 times 2x cubed plus 6y4. Easy as that. Okay? Just
Mm-hmm.
think about it like this. Something squared is this. So this is difference of squares, okay? Difference of squares. Now we're going to take it up one more level. We're going to do difference of cubes. And the formula for this one is a little bit more complicated. It's not that bad though. It's very, very similar, but it's a little bit different, right? It's a little bit different. So if it's add and subtract, oh, there is no sum of squares. There's no formula for a squared plus b squared. Okay? With squares, there's only a difference of squares, a minus b, a plus b. But when it comes to cubes, there is both sum of cubes and difference of cubes. Let's look at a quick example here. Just gonna show you a couple of these, okay? It's easier than you think. X cubed minus 64. Again, we're gonna use the same logic, right? We need it to be in this form, something cubed minus something cubed. Well, x cubed is x cubed. Something cubed is 64. Another way to think about this is, what's the cube root of 64? Something cubed is 64. Or you can just find the cube root of 64. You remember how to find the cube root of 64 on a calculator? You gotta change it into exponential form. So you do this, okay?
Is
So,
it
yeah,
1/3?
yeah, but you need to put the 1
Okay.
over 3 in a bracket. Yes, it is 1 over 3. To the power of 1 over 3.
4.
Exactly. So 64 is 4 cubed, okay? See, like that. And now we're gonna use the formula. It's a difference of squares, right? So we're looking at this one here. So what does it give me? Can you tell me what it gives me? Just follow the pattern here. It's not that hard. A cubed minus b cubed becomes what? A minus b, right? What's our a and our b here? It is,
X and 4.
yeah, x minus 4. and then you have a squared, so you have x squared, plus you have a times b, so you have x times 4, which is 4x, plus b squared, so plus 4 squared is 16, like that. And you're done, easy.
Okay.
That is all there is to it, okay?
Mm-hmm.
Sum of squares, difference of squares, just make sure it's in this form, and then you can just use their formulas. D. What's the cube root of 8x3? Because we need it to be in this form.
2x.
Yes. It's the cube root of 27.
It's 3.
Yes. So now use the same formula. What do we write? There's going to be two brackets. What goes in the first bracket?
2x minus 3.
Yes. What goes in the other bracket?
2x squared plus 6x.
Yeah? Plus what?
9.
Plus 9. But you said 2x squared, right? This is not quite right because it's a squared. A is 2x, so it's going to be 2x whole squared. What's 2x whole squared? What's 2x times 2x, I guess, another way of looking at it.
4x.
4x squared. There we go. That's the answer there.
Okay.
Okay. It's not that hard. It's just a little bit, I guess, getting used to. All right, let's do a very difficult one. I'm gonna do both of these guys. What is a cube root of 1 over 27x cubed? Well, you know the cube root of 27 is 3. So the cube root of 1 over 27 must be what? Cube root of 27 is 3, right? Just use logic. You don't really need a calculator. What's going to be with the cube root of 1 over 27? It's going to be 1 over 3, right?
Mm-hmm.
It was in the numerator. We got a 3 in the numerator. Now it's in the denominator. We're going to get a 3 in the denominator. Cube root of 1 is a 1. See that? Whenever you're trying to find the cube root of like a fraction, right? Let's say we're trying to find the cube root of 27 over 64. The cube root of 27 is a 3, so that's going to go in the denominator. The cube root of 64 is a 4. That's going to go in the denominator. All right, so 1 over 27 is 1 over 3x whole cubed minus. Tell me what's the cube root of 8 over 125. What's the cube root of 8? Think of it that way.
2.
2. What's the cube root of 125?
5.
5, that's it. 2 over 5. Cube root of 8 over 125 is 2 over 5.
Okay.
And then we're just going to use the minus formula where it says a minus b. So tell me what we get here.
1 over 3x minus 2 over 5.
Yeah, that part is easy, right? What about the next bracket?
1 over 3x squared.
So it's going to be 1 over, because a is 1 over 3, right? So it's going to be 1 over 3x whole squared. What is that going to be? In other words, what's 1 over 3x times 1 over 3x?
Do you multiply the denominator?
Yes, you do. So again, here, let me just, we're going to do a quick drill, right? Multiplying fractions, easier than you think. 2 over 3 times 5 over 8. Multiply the numerator with the numerator, 10. Multiply the denominator with the denominator. It's way easier than adding them. If you want to add them, then you got to look for common, the LCD, right? And then, yeah, multiplying is way easier. So just multiply the numerator with the numerator. 1 times 1 is a 1. 3 times 3 is a 9. What's x times x?
X squared.
There we go. That's going to be our first term. 1 over 9x squared. Okay, that's our a squared bit. Plus ab. So for the ab bit, we're going to do, okay, you try telling me this. A is 1 over 3x, b is 2 over 5. What's that equals to?
2 over 15x.
Yeah, that's it, right? 2 over 15x. What about the last term, b squared?
4 over 10.
4 is right, 10 is wrong. You're trying to do 2 over
25.
25, right? There we go. And final answer there. One and done. Fractions, no need to fear fractions. We don't fear fractions no more. Fractions is, so fearing fractions is, so grade 7 or grade 8. We're done with that. Now we own the fractions, okay? We're gonna show them who's boss. It's not that hard.
Okay.
Fractions or whatever. Let's try doing the next one here. This is already in the right form. Tell me what will this be? Because it's already in the right form compared to the plus one. This entire bracket, you see the first bracket is A, this entire second bracket is B. It's already in the right form. Maybe I need more space here because this is going to be a little bit longer. What goes here?
X minus 3 minus 3x minus 2.
Minus 3x minus 2. There's a mistake here. 10 points. What's the mistake? It has something to do with subtracting. Whenever you subtract something, okay? See this negative sign? It applies to every term inside the latter bracket.
Do you make a bracket?
You make a bracket. Yes, you make a bracket like that. Whenever you subtract, it's a good practice to put a bracket because the correct answer here would be x plus 3 minus 3x, but then plus 2. Okay? And then what's the like terms? There's some like terms. What does it simplify to? Actually, we're wrong because we're not using the right form. You see, this one doesn't have a minus. This one has a plus. So we actually don't have to even worry about the bracket bit. That's only when we're subtracting it, okay?
Okay.
Yeah, because there's a plus here. We use a plus. No need to worry about the minus. There's some like terms in here. What does that simplify to? We can clean this up a bit.
You can add the x's.
Yeah, so what does that give if you add the x's? You can add the x's, you can add the numbers. What's x plus 3x?
4x.
Right, so there's an x here, there's an x here. X plus 3x is 4x. What is minus 3 minus 2?
Minus 5.
Exactly, 4x minus 5 is what that bracket simplifies to, okay? 4x minus 5. And now we look at this a squared. A is x minus 3. So it's simply going to become x minus 3 squared. Tell me what the next term is. We just did this a squared bit, and we already did this.
So now you have to multiply.
Oh yeah, but we don't have to clean it up though. We just write what's the next step, right? So it's gonna be minus what times what?
X minus 3 times 3x minus 2.
Yeah, 3x minus 2. What's the last term? So we did the minus AB, yeah? What's the last term?
6x cubed minus 4.
No. I don't know where you got that from. It's just b squared, right? B squared. B is, so we do a plus here because there's a plus here. Plus 3x minus 2 cubed. Yeah, just like that. B squared. Where did you get the 6 from?
Oh, I was like applying the exponent to everything in the bracket.
Okay, you can't do that. That's the funny part. No. So for example, x plus 2 squared is not, this is a very common mistake. This is not x squared plus 4. You might be wondering, how is that? That doesn't make sense. Let's put some numbers in. Let's say x is 1, okay? Let's say x is 1. So we have 1 plus 2 squared, which is 3 squared, which is 9, right? Now look at this. X is 1, 1 squared plus 4, that's a 4. It is not equals to. In fact, whenever you have a squared, right? Whenever you have a square, that's going to be 3 terms, not just 2 terms. Same thing with cubed. Actually, something that we haven't done yet, but we should do this. When you open this cube, again, there's a formula way to do this. I can't quite remember what it is, but it's not easy. When you open this cube, there's going to be 4 different terms, not just 2 terms. So what that means is, again, it doesn't apply to Canadian high school. Yeah, this is something that also happens in the other program. Here we're strictly doing sum and difference of cubes, but in the other program we would do sum of whole cubes, something like this. When you open this, same thing as squared, this is not a cubed plus b cubed, okay? There's 4 terms here, 2 extra terms. So you can't open that bracket like that. So just leave it as this.
Okay.
Okay, so this is not gonna be like 9x minus 8 or something, no. Just leave the exponents on the outside. And that's all there is to this question. You just have to know what all the letters represent. So far, we've only gone in one direction, right? Not the band, but we've only gone in this direction. The beauty about maths is that you need to know how to go in both directions. So the next question, we're going to be given this and we're going to have to go backwards. Let's see. Which is this question right here. Looks very convoluted, right? Looks very difficult, but it is not difficult. So this person is claiming that this is equals to 1. Is he right or is he wrong? Look at this. What is this? Again, we're working backwards now. What is this equivalent to? Right, this is this guy right here. If I write this as something cubed plus something cubed or minus, what would that be? Again, we're working backwards now. Isn't this the exact same thing as this? Just capital letters, small letters. So what does that equals to? Well, that simply equals to a cubed plus b cubed, right? What about the next term? Why don't you tell me what the next term is equals to? This bit.
A cubed minus b cubed.
Right, so plus a cubed minus b cubed all over 2a cubed, like that, yeah? Does anything cancel out in the numerator? Are there any like terms in the numerator?
A cubed.
Yeah, so a cubed and a cubed are like terms. We're going to add them up. We're going to get 2a cubed. What about the b cubes? The b cubes cancel out because you have plus b cubed minus b cubed, yeah?
Mm-hmm.
Minus 2 plus 2 is 0. It just cancels out. So we're just left with a 2a cubed on the top, and we had a 2a cubed on the bottom. What is that simplified to?
1.
1. So is he right or is he wrong?
Right.
Yeah, he's right. He's smart. I don't know how we got this, but he's right, okay? That's all there
Mm-hmm.
is to this. It's a pretty short topic, I guess. Pretty simple. All right, let's call it a day there.
All right. Thank you.
All right, bye-bye.